quadratic will always have a minimum or a maximum value. Let's see how we can find that value. From the graph we can see that the minimum value of y is -8. Now how do we find that algebraically? We need to complete the square as we did in the last video. So we start off by taking 2 out as a common factor, and then we complete the square by halving the -2 and squaring it, and then we add it and subtract it to keep the equation balanced. We collect those first 3 terms there in the brackets into the perfect square of x minus 1 all squared, where we'll get the first term squared, the second term squared, and in the middle we get 2 times the first times the second, minus 2x. Now -1 and -3 will make -4, that we multiply by 2 to get -8. So the minimum value of y is -8 in that case, because to the -8 we're adding a squared term, and the smallest that a squared term can be is 0. Apart from that it'll be positive. And so putting x equals 1 in that part of it will make that 0, and the minimum value of y will be -8. We call that the turning point because the graph changes direction at that point. That is the minimum value of the function. Following the same procedure, we'll find the turning point in the general case. Starting with the general form of a quadratic, we'll take a out firstly, and then we'll complete the square by looking at the b over a term, halving it and squaring it, adding it on and subtracting it to keep the equation balanced, and then those first 3 terms will gather up into this perfect square. We will get the first term squared, the last term squared, and in the middle we'll get 2 times the first times the second. We'll gather these 2 terms here, and we'll have a common denominator of 4a squared with a -b squared there as a numerator, and this one we'll have to multiply by 4a over 4a to get 4ac in our numerator. Our denominator of 4a squared gets cancelled out with this 1a there, and so our denominator becomes 4a. Thus we can see that the turning point will occur when x is equal to -b over 2a to make that square term 0, and our minimum or maximum value for y will be this term at the end. It'll be a minimum value if a is positive, because to that value we are adding some amount, and the minimum we can add to that will be 0. And it'll be a maximum if the a is negative, because then we'll be subtracting away from that amount. So the turning point will always occur when x is equal to -b over 2a. And in practice, rather than trying to memorize this formula for y, we can simply work out what the value of y is when x is equal to -b over 2a to find our turning point. We can see that the turning point is halfway between the 2 x-intercepts. So we can actually find the turning point using that method. In the general case, the quadratic formula gives us the x-intercepts. And you'll note that we have a plus square root term and a minus square root term. So when we add those two together, they'll cancel each other out. And averaging those 2 x-intercepts will just simply give us -b over 2a, which is of course what we had previously. So we've seen that we can complete the square to find the turning point, and that it occurs when x is equal to -b over 2a. Using that value in the equation for y, we can then find the minimum or maximum value of y.